I've been working with Hadoop since its inception. And before that, I was building search engines for Yahoo and Ink2Me. So I've been working with big data since '96 by some reckoning. How do you crawl every document in the world and tear it apart and index it so that it can be found by the runtime search engine? That was kind of a decision that we made as a company, was that we want to actually put Yahoo on the map by building an open source big data system.
I really have a tough job sitting here, drinking, hearing the stories.
It's good to bring your passions together.
Yeah. Good, absolutely. Welcome back to Big Data and Brews with Eric 14.
Hello again.
So, well, as promised, we had a few more beers and we share a few more laughs here, a few more sips. So we stopped a little bit where the history of Hadoop got really interesting, right? So you said your team worked on your own system, and then you kind of got convinced or talked into adapting, that very, very early version of Hadoop that, run under the Apache license. So, well, let's double click a little bit on this, and I'm certainly curious about all the conversation and discussions you guys had. I mean, Ink2Me was all C++ based, right? You guys all hardcore, low level, deep down there. Now there's those guys coming along and say, hey, why don't we? Maybe those hippies, this development hippies, hey, why don't we do Java? Everything is good. We have garbage collection. And that's one of the never-ending stories and conversations and fights in the Hadoop lands. Like, why aren't you in C++? Right? Yeah. And what's maybe your experience with that as well?
Yeah, sure. So, so everybody on the original team at Yahoo was a C++ coder, right? So it wasn't a decision that we took without some consideration.
They had to learn a new programming language, basically?
They did. When the day I came into the staff meeting and said, guys, Ramy and I have been talking about it, and he's convinced me we're going to go with Doug Cutting's project. We're going to take all of our learnings and bring it into what was Nutch. We're going to create a new project. He's going to spin it out, and we're going to just commit to that. There were some very long faces. I would say it took them about 6 months before people started to see that this had been a good decision.
Yeah.
For about 6 months, I was the least popular person on the floor. But yeah. So why So why Java? First off, it was a bit coincidental, right? Mm-hmm. The thing that really mattered to us in the short term was that we were adopting an existing project, and that just completely changed the dynamic of the internal conversation about whether our company could contribute to open source. Because if you've ever tried to convince a company to make a major investment in an open source project, it's hard. I've watched a lot of companies that have made the decision that they're going to compete in the Hadoop ecosystem. I guess we should have stopped at 5 beers.
Yeah.
A number of companies that have decided they're going to compete in the Hadoop ecosystem, not just use it, but actually have Hadoop-based products, haven't yet figured out how to contribute to an open source project. So for a company whose business was something else entirely, it was a long, drawn-out process.
I think I remember Doug Cutting had to actually commit all the patches you guys did for the first, year or something?
It took us 18 months to really get to a fully normalized situation. So for the first 18 months, Doug was doing basically all the commits. Then we got Owen as the second committer, and they shared it. But that was a full-time job for them during that period. So yeah, it was pretty nutty. But in the end, we got there, and I didn't appreciate it at the time, but it was a really revolutionary decision that Yahoo did that. Yeah. So I give those guys a lot of kudos for backing us. But yeah, so the open source decision was really hard. So adopting an external project meant that it's a much easier decision to say we're going to improve something that exists versus to say we're going to take this our own artifact and move it into open source. It's just much harder for a company to do that. So our initial project, it made it much easier. I think we'd still be debating with the legal team if we'd built Juggernaut to completion and then tried to open source it. We wouldn't have succeeded yet. But that's illegal. In terms of Java, right? So, but part of it is, given that what existed was in Java, we kind of inherited that.
Yeah.
But in retrospect, did it make sense? And I think it made sense for a number of reasons. The first is just that Java is so much more productive, right? There's so much better tooling in terms of debuggers, in terms you don't have the garbage collection issues, you just have far fewer bugs to begin with, and then you've got, just all the free tooling to do all kinds of code analysis, all kinds of things. And yes, similar tools exist for C, but they're just, all the new academic work happens in Java because it's so much easier to do academic work in. So it's just a much richer set of tools, and it's a much easier language in which to write correct code, which meant that the first version of Hadoop was correct much sooner.
Yeah.
And that's not to be ignored, right? Because in this game, agility matters, right? Getting it right and getting it working and getting it out into people's hands is a huge piece of what's needed to make open source succeed. And so the fact that Hadoop was working and succeeding and visibly improving mattered a heck of a lot more than its ultimate performance in its first, even today, but certainly in its first few years of life. And I think Java really bootstrapped that. It gave us a lot of leverage in terms of the amount of correct working code we could get in people's hands quickly.
Yeah.
And the fact that it was slower than it might have been if it was handcrafted C++ code didn't matter as much as that it was there and it worked today.
Right.
But, and then that just actually gets, that factor can't be ignored, because in an open source project, when you always have new people coming in, the learning curve and the code correctness curve issue never goes away.
Right.
Right. So if you're going to have a project with hundreds of contributors that's doing complicated stuff, Java's a real advantage. Right. I mean, just code transparency and all those analytics tools and everything else, we really leveraged all that. So then you get to the, sort of argument about whether that doesn't matter. Ultimately, C++ could be better. There's people that'll stand up and say, that's just not right. Java can produce as good code as C++. And there's a case. We've been doing a bunch of work on Stinger Hive, where I've looked at, one part, the Impala crowd is doing, LLVM, right? Really tight C++ code. The other crowd is doing vectorized code and letting the JIT do its thing.
Right.
And really,
same thing.
It's the same thing.
Yeah.
I mean, it's not, the performance difference isn't that noticeable. Java has one real Achilles heel, which is that it's much harder to do dense memory management.
Right.
And so, HBasic, for example, or the name node, is a place where the amount of data you can put in memory really matters.
Right.
And you start having to invest a lot more to use memory effectively in Java. So that kind of obviates a lot of the advantages of Java. But that's kind of third order. I mean, first you need to sort of get there. And then at some point it becomes as complex as C++, but it's still not worse than C++.
Right.
So I think in the context of trying to build a big open source ecosystem, I think Java has been a huge advantage for Hadoop and all the people that have leapt up. And I mean, every year there's been a challenger to Hadoop, and every year these things have not proven relevant. Yeah. Right. So I'm pretty bullish. And I actually think a lot of folks, there's reasons why, over time will pieces of the Hadoop ecosystem be recoded in C? Maybe, sure. We're seeing, there's things in J and I in the main Hadoop code line now, and there'll probably be more in the future. But
compression, for example, right?
Yeah, compression, that's an easy one. And just system calls in Java are are terrible.
Yeah,
Right?
yeah.
So,
I remember the first version of Hadoop where Discrete was hard coded, a DF, right? So, yeah, so that was one of the main reasons why Hadoop worked awesome on Linux machines. As soon as you run it in Windows, if you call DF, it's of course a completely different command, right?
Yeah.
And the way it was implemented, it called DF, and then it passed the results. So if you actually go on like a different, Unix version where DF had a different syntax, you're all
trouble.
screwed. But it was the first time I saw that implementation, I'm like, wow, you really just executing a command and pausing the text that's coming back to make a decision like how much space can I use on this hard drive. But obviously things got better all the time, right? And
yeah, and I mean, I think Hadoop is getting to the point where in the future it's going to start driving its requirements into Java.
Yeah.
Right? And so that'll be fun to see how those things co-evolve.
right.
But no, I mean, there are limits to Java. I wouldn't argue that it's the right thing for everything, but I would argue that agility matters in this game, right? Because yes, you can statically code what's in Hadoop today better in C++, but what you want to be doing is not sort of recoding the inner loop for a 2x performance gain. What you want to be doing is taking all your learning from the last N years and building a new algorithm,
Right.
new data structure, new approach that's qualitatively better.
Yeah.
And Java's a better language to do that next version in.
Yeah.
So I think Java's going to continue to be the major language of Hadoop, or at least the JVM will be the major platform for Hadoop for the immediate future.
So as you started building Hadoop then with your team, how was the adoption path within Yahoo, and what kind of services and projects moved on there? Was it people that are more, right on it, and some people that came later on the game? I heard there was like a camp that really liked a database that starts with O, and then there was you guys, and so.
Not really an Oracle camp, but there's, how many 20-minute segments do we have to talk about this?
Well, we will make more, right? That's for sure already.
But, so, adoption was interesting, because, we spent a company like Yahoo, there's so many different organizations and teams doing so many different things. The first year or two of Hadoop, when we were just getting off the ground, we kept discovering other projects that asserted that they were also solving similar problems, and they wanted to figure out why we shouldn't abandon Hadoop and adopt their C++ framework
of course,
that they were using to manage data processing for their ads log pipeline or something like that. So for the first year, it was really just focusing down and saying, look, none of these other things that we're discovering internally solve the search problem. The search problem, our goal is to write something that can work at internet scale.
Right.
There doesn't exist such a thing. That's why we're building this. So we just had to sort of stay focused. But the next thing that happened was those guys that I told you had been coming into my office and saying, I want to do more research. You've got the crawl data, you've got the search logs. If I could get that, I could do better science and I could make more money for Yahoo, right? We kind of got to the point where we could make Hadoop work. When Doug took it out of Nutch and put it into the Hadoop project, it would work on about 20 nodes. We got it to the point where it was working on about 100 nodes. And then we realized to get it to work at the point where it could work on 1,000 nodes was going to take us another 18 months or so.
Oh, okay.
And, with all these other parties saying that they had competing systems, and it's hard in a company to not have a product for 2 years.
Right.
So we said, let's put out a Hadoop cluster for the science teams to just let them, that'll be a great proof of concept. It'll show the rest of Yahoo that we're building something valuable, and that'll keep our managers happy, right?
Right.
Guarantee funding, good thing. So it was really done just as we weren't thinking of it as our mission. We were thinking of it as a way to, to get, stop Arkady from coming into my office every month and demanding
where are the results,
and give the science team something to work with. But mainly it was just to show that we were producing value, because our goal was to rebuild the web crawl infrastructure with it. But that was just like I said, a long ways out. So we put it out in the science hands. And what we expected was they'd get some interesting, basically research results, maybe maybe they would get data results where they would, work on the data and come up with a new spelling correction dictionary, which would then get put into a production system. But what happened was they did all that and were very excited because basically we blew their minds. The productivity went up orders of magnitude because instead of spending their day trying to find data around Yahoo and then figure out what subset they could get on whatever storage they had, right? And half their time was spent doing IT work, basically finding and moving data and not doing research. And when they did the research, they would always have to do it on a tiny subset of the data.
Yeah.
Now they could just have all the data, move it once to one place, share it, and do their work. So they were just much more work productive. And because they had so much more compute resource, they could write their code in Java and be much more productive. So there was this explosion of research results. But more importantly, they started to build prototypes of production systems. They said, look, we want to take the ad logs and process them every 15 minutes to come up with a model of what people are interested in, and put that back into production every 15 minutes. And if we do that, Yahoo will make more money.
Right.
And that changed the game. All of a sudden, this created this completely unanticipated virtuous cycle where teams were demanding that we build and support Hadoop clusters for them so that they could build production applications, not in search at all. And so it just started to grow. I found myself running a Hadoop service with ultimately thousands of customers inside Yahoo and 40,000 nodes.
Wow.
But early days, it was not, people had to think differently to use it. There's this guy, Larry Heck, who ran the search and advertising science team, who saw what it could do. Originally there was this guy, Arkady, and couple of other scientists who used it and got good results. And then Larry saw this and said, I'm going to make everyone on the science team use Hadoop. And we started to maintain metrics of just, how many people on his team, what percentage of every subgroup was using Hadoop. And he started taking that to a staff meeting and asking people, why aren't you using Hadoop? Right? And so this just caused it to explode. And so, it was this huge unanticipated success where the science teams we thought of data science as something that was going to just produce, as a side project. But ultimately, it became a pipeline of new applications, and it drove most of the use of Hadoop and Yahoo.
What was over that period of time? I'm sure it changed, but just your first reaction, what was the most requested feature at that period of time?
Gosh, more data.
It
was mostly just more scale, more data. And then, obviously more speed. Just really the focus was never on more features. It was really always on just more stability, more scale, and more performance. Right? Really, when our first Hadoop t-shirts from the summits, said the Yahoo scaling Hadoop, right? Because that was it. It wasn't about new APIs. I think the APIs were satisficing for a lot of work, really, from the early days. I give the Google guys a lot of credit for that. And, Doug built something that worked in terms of the APIs. It was really much more about just taking on everything we'd learned and building internet scale systems. We improved the performance orders of magnitude. We improved the scale orders of magnitude. And that's a lot of engineering, a lot of learning.
Right. So let's switch gears here a little bit. What are the really cool things that going on right now as in today's world? What are you really excited in the Hadoop ecosystem, or what's going on in the Hadoop backend?
Well, it's a tremendous amount of stuff going on, of course. Obviously, the transition to yarn is very exciting, right? That has been a journey we started. I'm afraid to guess when we really started that.
Can you explain this a little bit more for the folks?
Sure. So the original Hadoop version,
if you want
to, I don't think there's a lot of drawing. There's a lot better diagrams you'll find on the web. But the original Hadoop version is built with basically two systems. I haven't used a chalkboard since I TA'd.
Isn't that fun?
So that's taking me back to 95. HDFS and MapReduce are the two basic layers of Hadoop. So each of these runs, basically you have a daemon on each node. HDFS handles your storage, MapReduce handles your compute layer. So the problem with the MapReduce layer is that it assumes one model of programming. Right? It assumes that, and it's a very powerful model of programming. Look at all the things people have done with Hadoop. But there are, of course, many other possible ways that you could approach distributed computation or just cluster sharing.
Yeah.
A lot of what people do with Hadoop is actually very simple things that you could do on cloud. You just need to launch a process and do some computation on the data.
Yeah.
MapReduce wasn't designed for that, and it certainly wasn't designed for running, all these new frameworks that are emerging.
Right.
And even worse than that, because every time you change MapReduce, you have to change all the daemons across all the nodes in your cluster. Even just evolving MapReduce has been relatively slow because you have to do it carefully. So we had this thought, which was, what if we break it into 3 layers, basically? HDFS Yarn, which technically stands for Yet Another Resource Negotiator, but really we just wanted a name with a Y in it so that people knew it came from Yahoo.
Okay.
And then we could have multiple frameworks on top.
Yeah.
So you could have MapReduce. You could have, let's say, MPI was one we thought about a lot in the early days, although that hasn't really been realized yet. You could have lots of others. Today, draw the list, right? Storm is really interesting. Spark is coming along. Both of those are happening at Yahoo today. People are looking at sort of container, sort of web app containers like Tomcat and figuring out how to run that in the cluster. You're just all kinds of long-running services, and HBase, that's a fun one to run in the cluster, right? So, so anyway, so the idea is lots and lots of different frameworks. Every user can choose a different kind of compute model. In Yarn, instead of MapReduce, basically was doing 2 things. It was doing resource management, choosing...
But hard-coded more. For its own purpose.
Exactly. So the resource management is deciding what resources you get on what nodes, and then the actual logic of the MapReduce. Right? Where does the user code run? What happens when a node fails, etc. So we broke that up into call it a user component and a system component. Now, one of the reasons we did this was not even so that you can run lots of frameworks. It's that so you can evolve MapReduce more quickly.
And you have maybe multiple versions. It's almost kind of a class loader or virtualization framework.
Exactly. Yeah. So now if you believe you can improve MapReduce, that just becomes something that you can run a test version of from your desktop and see if the new one and the old one are better. Whereas before you had to go and change the cluster, schedule downtime, lots of pain.
Yeah.
So it will make all the existing work much more agile, and it'll also hopefully just untap huge amounts of innovation. So watching that innovation is going to be really interesting over the next few years.
Eric, thank you very much for joining me for drink here at Big Data and Brews, and hope to see you back soon.
Yeah, it's been fun. Thank you.
Cheers.